When I see my daughter having a glass of water today, I can't afford to think about an emerging water problem. Is she having a pharmaceutical soup from our tap? Because today's reality is painkillers, hormones, and antibiotics are only some of the pharmaceuticals that have been found in our drinking water. So you may wonder why this is happening. There are two main reasons. First, new technologies are helping us to identify these pharmaceuticals at very low concentration. And second, we are actually having more and more pharmaceuticals or pharmaceutical drugs. And some of these drugs are actually going into us, through us, and out of us totally unchanged. So we actually have active drugs going into our waterways through our urines and feces. So the bottom line is, if we are having it, we are also drinking it. So what are the long-term health effects of these pharmaceuticals? Unfortunately, we don't know yet, because there are no national standards for monitoring these pharmaceuticals in our drinking water. My name is Arif Alam, and I'm working on developing a low-cost and easy-to-use sensor which can detect these pharmaceuticals at very low concentration. You can imagine the structure of my sensor similar to having a magnifying glass, which I can hold on my hand, and I can see the objects through my eyes. So the first part of my sensor is a magnifying glass-like molecule, which is called beta-cyclodextrin. This beta-cyclodextrin can actually capture the contaminants from the water, such as painkillers and hormones. And the second part of my sensor is similar to my hand, which actually corresponds to a rolled sheet of carbon atoms called carbon nanotubes. These carbon nanotubes can actually transport the sensing signals from the pharmaceuticals to my sensor. And finally, the third part of my sensor is actually similar to my eyes, which corresponds to an electronic readout circuit. This electronic readout circuit board can actually receive, process, and analyze the sensing signals that are coming from the pharmaceuticals in my drinking water. My next research goal is to deploy these sensors in a remote and small First Nation community so that they can monitor the quality of their drinking water. I believe the sensor that I have developed can contribute to having safe drinking water for our future generations, including my daughter. Thank you.